One housekeeping item for me, this is the first time I do a public presentation with braces. So if you guys need translation from my words, blame my dentist, not me. So I will try to speak really slowly. It's hard to speak in public with braces. I did just 1 month with braces. So yes, I authored the Singularity plugin for Nomad for last year, HashiCorp. And this year, I'm bringing you new tools and integrations with all the Hashi stack, and how can you not just run performant containers, but also secure containers. Okay. But to kickstart, I want to start with this, right? So some months ago, I was preparing myself to go to DockerCon, have an awesome time, and boom, Docker Hub is breached. Some credentials are hacked, and then someone has access to your private, maybe repos in Docker Hub. And this brings a new topic into the table for security, and is that everything is intellectual property these days. So people say, yeah, but my data is in a private database or something like that. Not that much, right? For companies like mine, and I know a lot of customers that we work with, your container itself, the binary that is processing the data, is the intellectual property of your company. And with this, the Docker Hub breach and the other container registries out there, then people is starting to get interested in how can I protect my containers when they are up there in the cloud, right? So it's not just protecting the data in a database, but also protecting that binary that is going to chew that data and give me insights from the data, because that is also intellectual property. And when I talk about intellectual property in a binary, then I'm talking about data protection, data regulation, data provenance, data compliance, and all these small buzzwords that give the creeps out of all the developers today. So we have HIPAA, we have the GDPR regulations, and more to come that are bringing new headaches to developers on how to work and how to store containers. So one example of people that I work with, which is bioinformatics people, which is related by HIPAA, if you are using one container, one single container to process a DNA or to process some medical procedure, you need to store that container for 10 years, right? And you have then two issues. That container is now intellectual property for your company. That container can become potentially like a patent or something like that, and also you need to keep that container alive and running for 10 years in order to be HIPAA compliant. So, you know, containers are not just a binary that chews data. You are getting into protection of and regulation of data with your containers. So it's now important now to protect that binary inside your container. I'm super happy to bring this example to you. So my wife worked with Reallife Containers, so it's a very interesting family. This is how they sign and encrypt a real-life container. So this picture was taken by my wife. And so a police agent checks the content of the container, then puts a blue lock. And the other, I would say the white lock, is set by the FedEx or the private corporation to ensure that both the police and the private corporation are assured what is inside the container, and those locks can only be removed by the owner of the content of that container on rest, right? So thanks to my wife for that picture. So who am I? Before going more in depth, Eduardo Arango, software engineer, a little bit of developer advocate for Scilabs. That's my Twitter handle. That's my GitHub, where I post a lot of integrations and cool hacks weekly. So quick recap. For HashiConf last year, I wrote the first plugin for Nomad. So they were releasing the beta in that conference. And I took some time with the Nomad engineers to write that plugin just before my talk. And that plugin now has 2 releases. I call them alpha. I've been really scared to call one beta production ready. I think in the next couple of months, I'm going to release the beta and waiting for more user testing. So right now, I'm in conversations with some users People like in CERN, people in some universities are already trying this plugin. So quick recap from last year's conference. So the message that I want you guys to take home is HashiCorp is unlocking the operational model for cloud, but then Scilabs with Singularity is going to enable trust in your DevSecOps lifecycle. So let's talk about container images. What are you storing in your containers, and where are you storing your containers? After the Docker Hub breach, Microsoft published a really cool blog post about that everyone should have an on-prem container registry and not trust the cloud container registries. If you are working with sensitive data, or if you consider your containers intellectual property of your company. And if you're going into a multi-cloud deployment, you should have a container registry on every cloud provider that you are working with, and not trust a single container registry in a single cloud provider to go multi-cloud, right? So again, we are storing our company property in different clouds, and we don't know who can access that data, and if a developer that I just fired has that container in his laptop and can then just use that binary to process data and to get insights from other kind of data. So to get everyone up to speed, this is how our OCI container looks like. So we are storing data in layers, right? So for everyone not familiar with how a container looks inside, this is a OCI container. Every change is stored in a own layer that then is wrapped up and called a container. But at Scilabs, we were studying this and how to secure your containers. And we call that layers do not work when encrypting your data, and do not work when you try to run that data encrypted, right? So right now, there's a real cool issue and a PR already open to integrate encryption for OCI layers. But what this process is doing is that every layer that you see there is going to be encrypted. But before going into the kernel process pool, all these layers are going to be unencrypted somewhere in your hard drive and then run by your Docker, Podman, whatever runtime you're using. So there's a small second there on which your data is available on disk, right? Because you need to decrypt these layers. At Scilabs, we developed what we call the single image format, or some call the Singularity image format. It's a single binary that can host the metadata of what is inside that binary, and then you can have layers, right? You can also call them layers, but everything is packed in a single binary. So you can call it a tar file in steroids, and it's open source, so that's the GitHub repo. You can go there and try to plug it up for your protecting your data, and it works right off like a tar file. So you can add info there, take info from it, and I'm then going to show you how can you work with this image format with Singularity. How are we running encrypted containers? We are using the super old school Lux, the Linux disk encryption. So what you see here that we call the immutable runtime container image is really an encrypted file system using Linux old school tools. So I'm going to show you how that's done. Here. Is that okay? Everyone reset? Okay. So the first thing that I'm going to show you is what is SIF, right? So here I have 3 images. I have so this is how a SIF container looks like, right? So I call, okay, SIF, Singularity, tell me what is inside this SIF file. And it is calling me the definition file and the file system. The definition file in Scilabs is what everyone in the industry will call the Docker file, right? For us, it's how you define your container, a definition file. So it is telling me that inside this single binary that I can check as a Unix file is containing a file system and a Docker file, or a definition file for us in Scilabs. But then if I point Singularity, to a Signet container, it is going to tell me that it also contains a SHA signature. So I was showing you here that it can be cryptographically signed, right? So this single binary can also store your signatures. And I'm going to show you how can you play with those signatures in your container. It's a VM, takes time. So I can call Singularity to verify a container, and if the container doesn't hold a signature key, it is going to throw a really sad message telling that the container is not signed. So this is. Your container cannot be verified. It doesn't contain a signature, right? And by doing this, you then can add trust to your DevOps cycle, right? And you can add multiple signatures to a single container. And then I'm going to show you how can you, with Singularity, manage those signatures. So the workflows that we are seeing right now in government facilities using Singularity containers and this signature and verification is that the developer needs to add his signature saying, okay, what is there? And if this container breaks something, it's my fault. Then his project manager is going to sign also that container, and then the security team, when reviewing the container, will add their PGP signature to the container, and then the container will have 3 keys, and the ops team will then trust that container, and they will say, okay, 3 people review this container, it has 3 keys, what can go wrong, right? So it's a way of adding trust to your containers. But with Singularity, you can then manage these keys in every system with what we call the ECL, Execution Control List. So here it is. So this is a file that is stored in the whatever configuration path you give for Singularity, and you can create exec groups, right? You can create blacklist, whitelist for keys, and you can create list. So not just a single key, but multiple keys for reviewing a container. So when we call blacklist, and why we added the blacklist and not just whitelist feature, is that let's say you fired an engineer or you fired someone from your company, you don't want to keep running containers signed by that person, right? So you can then add that person's signature to the blacklist, and Singularity is never going to run that container if that container comes with that person's signature. And also, if you enable this is disabled right now, if you enable it, if the container doesn't have a signature, it is not going to be run because Singularity doesn't know it is part of the whitelist or blacklist, so it is going to fail. So if you enable this feature, you will always need to sign your containers. Now, some question that we always get is, how can I port my already OCI containers into Singularity? We support every OCI registry out there from Microsoft ORAS that we just 2 or 3 months ago added support. You can pull containers from the Microsoft ORAS registry, NVIDIA container registry, Docker container registry, Quake container registry. As long as it honors the OCI API, we can pull that container for you. So I'm going to pull a container into a CIF format from Docker. Oops, I missed a T. latest. There is Singularity run. So I just pull a container from the Docker registry, store it as a single image file, as the binary. Then I can sign and trust that container, and I run it with Singularity really easy, right? So if I do Singularity, I can see that, Docker, yeah. I can see that it comes with the JSON generic that is part of the OCI image spec. So you can then also review that this is an OCI container. It has the file system of that container and a definition file that would be empty because I didn't use a definition file for building this container. Oops. Now, what you guys are looking at there is I have a boat running and a Nomad running. So I'm going to show here. And you can see that here we have a living Singularity plugin inside that Nomad that is running here. And I'm also going to show how can we encrypt a container and give the keys to both, and both is going to be the key handler for that container. So let's use the container we just pulled from Docker. It isn't, oh, I need to rebuild it. So here I have a file system that is raw. So it's like when you have a OCI image in your disk. And I'm going to build that. Here. And I'm going to build that zip file using that raw file system, and I'm going to encrypt that container using both as the key manager. Running encryption in a 2-core VM, it's not that fast. Why on demo takes longer? I run this like 10 times before entering here. OK, so it is encrypted. So if I try and run in that container, it is going to fail. Oops, run. I don't have the keys. Only both has the keys for running that container. So here, both passes Singularity the keys to decrypt the container and run the container, right? So the keys were never exposed. It was just both talking with Singularity to run an encrypted container. But then, what we are all here is to see how can we plug everything together and use both with the Nomad plugin to run encrypted containers using the hash stack. So this is a Nomad job file, and do I have? So here you can see that by using a template, I'm calling both with a policy that I created. It's called demo, is read only. So both is going to expose the Singularity encryption passphrase when running the job to the container on where we were last time, the path. So here in the image stanza, we can point to a local container or to a cloud container, right? So here I could also say Docker, whatever, or library, which is the Scilab's registry. So it can be a local file, a NFS path, or it can be a registry path, right? So you can point it wherever you want. So it tells me that everything is good to go. There it is. So both and Nomad, as they are really tight integrated by the hash stack, both passes the keys to Nomad, and Nomad exposes the keys to Singularity to run that encrypted container, right? So here I'm showing how can you use the full hash stack to run encrypted containers and protect your data by running the data, right? So for those that knows the Lux file system, it is encrypted even by running it, right? The only way you can have this container is to get my hard drive, right? And try to decrypt my hard drive is the only way. So a couple of milestones of why are we here? So this zip file was really released last year, at the beginning of last year. At HashiConf, we developed the Singularity plus Nomad plugin. And the encryption of containers was released, I would say, a month ago. And now we can see how both can manage those encryption keys and pass it over to Nomad. So we can schedule encrypted containers and then decrypt them at runtime using both. So wrapping up, I still have time, so I talk really fast sometimes. You should care about data protection regulations and what are you putting in your containers. A lot of people think that what is inside a container is just the binary, and the binary doesn't care. What cares is the data in the database. Well, with all this HIPAA and GDPR and everything that is coming to the developers right now, the binary itself is data that we should protect. So that's something that I want you all to take home. And that using both Nomad and Singularity, you can then enable DevSecOps, right? So it's not just running encrypted containers, but also adding the signed and verification of containers by adding these PGP keys to your zip file. You can then control who runs containers in your host by using the execution control list. So once again, HashiCorp is unlocking the multi-cloud model, and with Scilabs on top of the Hashi stack, you can enable trust for the DevSecOps in your company. Thank you.